Good morning and welcome to your next session of science lessons for online learning. My name's Mrs. Chiverton. I'm one of the Associate Directors of Science and I'm going to be teaching you 6 lessons on our planet Earth and in particular the rocks that make up our planet Earth. And lesson 1 today is going to be based on the topics of weathering and erosion. So, what do you need for today's lesson? You are going to need something to record your answers in, whether it's an exercise book or some paper. You're going to need a pen, pencil and ruler because the easiest way to record this is as a table. And I'm going to give you a minute just to go and collect that information, those resources. And when you finish, you can get your brain in gear by having a go at the simple starter activity on the PowerPoint now. How many words can you actually produce from that word weathering? Off you go. Okay, hopefully that's got your brains thinking somewhat. Now, I've got a question to pose to you that you may or may not be able to answer at the moment, but hopefully by the end of this session, you should be able to actually answer this in quite a lot of detail with lots of scientific terms. So in front of you, you've got the pictures of 2 mountain ranges on planet Earth. We've got the Himalayas over in Nepal, the highest range of mountains in the world, and much closer to home, we've got the Scottish Highlands. Now, currently, the highest mountain in the world is Mount Everest, whereas the highest mountain in Britain is known as Ben Nevis and is found in those Scottish Highlands. Ben Nevis is an impressive 1,344 metres high. Mount Everest, however, is an incredible 8,848 metres high, far higher than the Scottish Highlands. However, scientists are aware that the Scottish Highlands, in fact, used to be bigger than Mount Everest. And the question I'm posing you is, how did that happen? How have things changed so much that Mount Everest is now so much taller than Ben Nevis? So, in terms of our learning outcomes today, the challenge for you is going to be able to describe the changes in rocks due to physical, chemical and biological weathering. And the aspire is that you should be able to explain those changes using ideas about expansion, contraction, chemical reactions and biological processes. And if you can do all of that, you should be able to answer that question about the Himalayas. So, we're going to concentrate on weathering first of all, because weathering is responsible for breaking up rocks. And what you can see in the pictures on the screen now are some incredible images of rocks that have been weathered and have been broken down, damaged and changed shape to leave these very impressive figures that you can see there in front of you. So, some work for you to do. Types of weathering can be split into 3 main categories: physical weathering, chemical weathering and biological weathering. I'm going to give you 30 seconds to just make a version of this table in your exercise book or on your paper in order to record some notes about the 3 types of weathering as I go through the PowerPoint with you. So you've got 30 seconds starting from now. Okay, so we're going to concentrate on physical weathering to start off with. So temperature changes can break up rocks. It's quite a dramatic process, but it happens over a period of time. And this is called physical weathering. And there are two main types of physical weathering that you need to be aware of. The image on the right shows a picture of some freeze-thaw weathering. Okay, not easy to say, but quite easy to explain. And the second image shows something called onion skin weathering. So both of these are responsible for large bodies of rocks gradually being broken up into smaller pieces of rock. And we need to be able to explain those. So, question to think about. What do you think will happen when I put a jar full of water into the freezer? Now, some of you might have seen this, or some of you, in a science lesson previously, but I'm just going to give you 30 seconds. You don't need to write anything down. Just have a think about what you think might happen if that jar full to the brim of water with the lid screwed tightly on is put into a freezer and left there for 24 hours. Okay, well, I'm pretty sure you'll have all said it would have turned into ice, but I'm not sure if all of you understand that when water turns into ice, it actually expands. And what you would have seen is this. So, as I said, the water expands as it freezes. And in doing so, because it's got bigger and wants to take up a bigger space, it actually exerts forces on the sides of the bottle that are holding it in place. And eventually those forces are big enough that they can actually shatter the glass bottle. And this is what water can do to rocks too over a period of time.
Believe it or not, the rolling countryside of Cornwall in southwest England used to look more like the Himalayas or the Alps. Mountains don't last forever. They gradually wear away at a rate of about 10 centimetres every 1,000 years. So all that's left in Cornwall today is a series of domed shapes, giving the landscape its rolling appearance. Changes in temperature from day to night and the expansion of freezing water cause rocks to wear away. When water enters a crack in a rock, it expands as it freezes overnight. When the ice turns to water and freezes again, it forces the crack open a little more. As the water seeps even further, the crack widens. This freeze-thaw action is repeated. It eventually causes pieces of rock to break off. They fall down the mountainside, where they lie as pieces of jagged rock known as scree.
So the next method we need to consider is the onion skin method, which also involves expansion and contraction, but this time it's actually of the rock itself. If you look at the first picture, you can see there an example of a rock being heated up by the sun and the actual surface of it expanding. So this kind of method usually takes place in places where there are large daily changes in temperature, such as deserts, where the temperatures can range from 40, 50, even 60 degrees during the day down to 0 or below freezing, in fact, at night. And the expansion of the rock actually occurs, and it occurs more on the surface of the rock than it does on the centre of the rock, because obviously the surface of the rock is absorbing more of the heat. So the surface gets the hottest and therefore expands the most, it gets the biggest the most. At night, when the temperature cools down again, the rock will contract, and again it will be the surface of the rock that contracts the most. And this process, this continual process over many days, nights, months, etc., will actually cause cracks to appear in and around the surface area of surface layers of the rock. And what will eventually happen is some of those surface layers will literally peel off as smaller pieces of rock, a bit like an onion having its outer layers removed. And as time goes on, the rock will get smaller and smaller, with smaller chippings being taken off it. In addition, if a rock is made of many different types of minerals that contain crystals, they may actually expand and contract at different rates, and therefore that can also cause cracks and cause bigger chunks of rock to be lost from the actual rock surface. So both of those types of weathering fall into the category of physical weathering, where we're relying on expansion and contraction of substances, either water or the rocks themselves, to actually break apart the larger rocks into smaller rocks. I'm going to give you a minute now just to record anything you can about physical weathering into the column to do with physical weathering on the table that you did previously. If you need longer, you can pause this video now and spend more time, but there will also be time at the end of the video with a summary to enforce what you need to know. Okay, that's the minute up. As I say, if you need more time, please feel free to pause this video and take some more time to record that information. Right, I'm going to move on now to the second type of weathering, which is chemical weathering of rocks. And as you walk around your towns and villages, I'm sure if you look up at the buildings and the statues around you, you will see similar examples to what I'm putting up on the screen now. So some of the most famous statues in the world have changed dramatically from those crisp carvings produced by their sculptors. And this is often due to chemical reactions with acid rain. So we've got some Easter Island statues there, and we've got the Sphinx from Egypt, all of which were probably much crisper and clearer images when they were originally carved many years ago. And the changes are due, in the main, to acid rain. So this is an example of what can actually happen. The statues are all made of limestone. The original design is shown at the top, and they have been left in different situations for over 20 years. And you can see that where there's been relatively low rainfall, even if the pH is pH 7, which is neutral, or slightly acidic, pH 5.5, then there has been some weathering of the statue, but not a huge amount. The bottom pictures, on the other hand, show the same pH of rain, pH 7 on the left and pH 5.5 on the right, but where there's been much, much higher levels of rainfall. And you can see how much difference there has been in the actual statues over that 20-year period. And that is because the acid in the rainwater actually reacts with the limestone and gradually dissolves the limestone, forming other chemicals, and so eroding away at the statue. So, chemical weathering. Most rainwater is naturally slightly acidic because it dissolves some of the carbon dioxide from our atmosphere into it. So it usually has a pH of slightly less than 7. Acid rain, however, contains dissolved pollutants like sulfur dioxide and nitrogen dioxide. Now, these have been produced in the last 200 years by our burning of fossil fuels. So sulfur dioxide and nitrogen dioxide are produced when we burn fossil fuels in power stations to generate electricity, and in all of our motor vehicles, such as cars, lorries, buses, aeroplanes, and so on. So in the last 200 years, the levels of sulfur dioxide and nitrogen dioxide have increased in our atmosphere, and as a result, a lot of rain has become far more acidic. So in other words, as the substances dissolve in our rainwater, it decreases the pH of the rainwater, often less than 5.5. And that acid rain reacts with minerals in the rocks, so they get worn away more quickly. It does depend on the type of mineral that is in the rock as to how quickly they react, and some of them don't react, which is why in graveyards you often see some gravestones that still look very crisp and sharp, and other ones made of things like sandstone and limestone that have been eroded quite quickly. And over time, it can cause larger rocks again to be broken apart, where rocks have been eroded away, cracks form, and other types of weathering can contribute to this as well. So these are some examples of things that have been chemically weathered. On the right hand side, you can see some statues and carvings on around buildings and gravestones, as I've mentioned. And on the left hand side, you can see some chemical weathering of natural phenomena. And those holes and so on in the rocks are often a result of different minerals being weathered at different rates by the acid, depending on how well those minerals actually react with the acid in the acid rain. But again, quite dramatic changes over time. And as it erodes things away, then eventually gravity may come into play and break off huge chunks of those rocks as they gradually are damaged by the acid rain. Okay, so I'm going to give you again about a minute to record any information you have about chemical weathering. Again, if you don't have enough time in that minute, feel free to pause the video, and you can always check your answers from the summary sheet at the end of the presentation. So biological weathering. This happens because plants often use the wind to spread out their seeds. When a seed falls into a crack, it quickly germinates because of the moist shelter conditions, and you can see an example there of a plant apparently growing out of a wall. However, as the seedling and its roots grow, they put pressure on the crack and cause it to become deeper and or wider. Plants like ivy can cause similar damage because they cling to buildings by root systems that again penetrate cracks between the bricks. So as they grow up the building and their roots penetrate in through cracks, again that pressure that they put on them causes them to become deeper and or wider.
Lichens, algae and fungi that grow on the surface of rocks release chemicals that react with the rock material, damaging it. The spaces thus formed can become inhabited by other plants. The plant roots make their way into tiny cracks in the substrate rock. As they grow and expand, they contribute to the widening of these fissures, and finally they cause the rock to split apart. Small animals loosen and break up the upper layer of partly weathered rock, thus enabling destructive factors to reach the deeper, previously untouched layers of rock. This type of weathering is referred to as biological weathering, because it involves live organisms that produce chemical substances that react with the rock material, the tearing apart of rocks by roots, and the activity of animals.
So here are some examples of biological weathering. The plants and trees in these pictures have not been surrounded by the rocks haven't been moved to surround the trees, in fact quite the opposite. Tiny little seeds and seedlings have grown and expanded and pushed forces on the rocks that it's actually dividing up huge areas of rock and actually splitting in the top left hand corner there a rock completely in two, just due to the forces of the plant growing through it. On the top right hand column you can see again that a plant growing at the top of a cliff face is actually causing fissures all the way down through the cliff face, and eventually that whole cliff face will actually divide itself. And the final picture at the bottom there, you can see those roots that are growing as a network throughout those cracks and will cause more and more breaks in the rock to actually occur. And all of these are examples of biological weathering. So again, this is your opportunity now to record all that you know about biological weathering. And again, I'm going to give you about a minute in order to record that information, but feel free to pause the video if you wish to do so. Okay. Right, finally, we're going to talk about erosion. So erosion is that movement of the small particles of rocks so they're transported away from where they were actually formed. There are a variety of methods of erosion that can happen, and over time it can dramatically change landscapes. So once weathering has happened and rocks have been broken into smaller pieces, then erosion usually follows. So this example is a picture of erosion by water in a river. And so again, you can see that process where the land is now split by the river and it's actually eating away at the surface of the land and causing a gully. We've also got erosion by waves against a cliff. And again, we can have that mechanical breakup of the actual rocks themselves, and then the cliffs will move those pieces of rock away from the actual cliff surface and again gradually eat away at the surface of those cliffs. And then one of the final methods that you need to know about is erosion by the wind. So erosion by the wind, again, as you can see in this field, is whipping up really small particles, but it can move larger particles as well, depending on the strength of the wind. And it moves those particles that have been weathered from one place to another. So actually changing the landscape that we look at. So we go back to that original question that I set you. We know that Mount Everest is currently far, far taller than Ben Nevis, but we also know from scientists that at one point Ben Nevis and the Scottish Highlands were actually taller than the Himalayas. And so therefore we go back to that question, how is it that the Scottish Highlands used to be bigger? Now we're at the end of the information, and this question will be task 2 on your Google Forms to actually fill in and answer as an extended answer question using the information you've recorded from the videos today. This is a summary sheet of all of the information main points that you needed to get. So if you've missed any of those points or you want to actually add any other information to your points, you can do so now. When you've had a chance to do that, or you're happy with the answers that you've already recorded, then you can complete the Google Sheet, which has a simple 10-question quiz, multiple choice quiz for you to answer based on today's lesson. There's the extended answer task to answer our question about Ben Nevis in the Himalayas. And then finally, there's an extended answer extension activity that you are also welcome to do. I hope you've enjoyed this, and there will be a series of another 5 lessons all about rocks to follow on soon. Thank you for listening today.